It's a kernel, the core that manages hardware, memory, processes, and communication between software and hardware. You interact with it using a shell, the command line interface, like Bash or ZSH, where you type commands to control the system. That shell runs inside a terminal, a program that gives you access to type and run those commands. When you run a program, Linux creates a process, each identified by a unique process ID, PID. Many of these processes are managed by an init system, like systemd, which is the first process the kernel starts and is responsible for launching services. Some of these services are daemons, background processes like SSHD or cron. Scripts and commands often rely on environment variables, like $path, which tells Linux where to look for executables. You can connect commands together with pipes, sending the output of one command as input to another. stdin for input, stdout for normal output, and urits for error messages. Files themselves can be connected using symbolic links, shortcuts that point to another file or directory, or hard links, which are alternative names pointing to the same data on disk. Storage devices like USBs or partitions are added into the system by mounting them onto directories. To connect securely to another computer,
You use SSH, which encrypts your login and commands. When you need administrative power without logging in as root, you use sudo, which lets a normal user run privileged commands. To monitor what's happening on the system, commands like top or htop show you active processes, CPU usage, and memory.
common types are ext4, XFS, and BTRFS, each offering different performance and features. Kernel and system messages are stored in the DMESG log, which is useful for debugging hardware issues. For full machine-level separation, Linux supports virtualization through KVM and QEMU, allowing you to run entire operating systems inside Linux. Linux can share files with NFS or Samba, transfer data with SCP or RSYNC, and host services using web servers like Apache or Nginx. Monitoring networks is also possible with tools like TCPdump and Wireshark, which capture packets for analysis. Linux distributions bundle all these concepts together differently. Snap and AppImage allow applications to run across many distributions without compatibility issues. Linux also relies heavily on systemd services, which can be started, stopped, enabled, or disabled to control background tasks. To see what's happening during startup, you can use systemd-analyze
To check boot performance. If the system fails to boot properly, you can use recovery mode or a live USB to repair files and restore access, which provides the graphical interface users interact with. Another key concept is shell built-ins, commands built into the shell itself, like cd or echo, which run faster than external binaries. You can also use aliases to create shortcuts for long commands, making your workflow faster.